So when you want to talk about, okay, so n is equal to 5, the range of x, the interval of x is 0 to 1. So what should I do? I want to find I have to first find the width of the rectangle, am I right? Every time when you want to draw upper rectangle or lower rectangle, you have to find the width of the rectangle. So may I know what is the width of the rectangle? Is equal to 1 minus 0 divided by 5. So make it easier, 0.2. All right? Okay, so how is the x cube graph look like? So you have to sketch the graph. So x cube graph will look like this. I just do one part. All right? This is my y equal to x cubed. So, are you okay? So, the very first thing I will do is I put this into my y1. Okay. So after that, since the width is equal to 0.2, so it starts from 0, you add 0.2. All right? Then from 0.2, you add another 0.2, it will be 0.4. Then from 0.4, you add another 0.2, so it will be 0.6. It will be 0.8. And the last one is 1.0. Correct? Hello? So now you see, you got 1, 2, 3, 4, 5. 5 rectangles. So we want to draw an upper and a lower rectangle. When you say AL, okay, I'm going to go to B. When you say AL, it means sum of the area of all lower rectangles. Okay? So in this case, if I draw lower rectangle, the first rectangle will be like that. So I use red. The first rectangle, you give me 1 minute. Okay. So the first rectangle will be here. Lower. Because between x equal to 0 and x equal to 0.2, the y coordinate at x 0.2 is bigger. So you want lower, so you have to take, so the first rectangle, so when we do the calculation, so my AL will be equal to, the width is 0.2. So the height of the first rectangle will be taking as y10. Clear? So the second rectangle, okay, now second rectangle is here. Lower. So I have to use y1 0.2. Correct? Hello? Do you get me? The lower rectangle, you take the lower height, the shorter height. So the shorter height happens when x equal to 0.2. So you get the y coordinate when x is equal to 0.2. Do you get me? That's why I write here y 0.2. So it go on. Are you okay? And it go on. And so the second one, so this is the first one. Second one, third, fourth. Okay, so the third one will be y1 0.4 plus y1 0.6. Okay, this is the fourth one. Then the last one, the fifth one, is when you use your x equal to, then you draw your, these are all your five lower rectangle. Do you get me? Okay, so you got this. Then plus the last one, y1 0.8. So you will get, they call rational number. Rational number here means real number. Are you clear? So what do you get? Yes, what do you get? So you can check from your book. Yeah. So you just use your calculator and you get the answer. Okay, so for upper rectangle, so when I draw, okay, if in the exam they expect you to draw two, usually they will give you two graphs. So now I have to sketch another one, same thing. This is my y equal to x cubed. Okay, so I also go by the width first. Yeah, always start with the width from 0. Go to the next one. What is the next one? 0.2. Then the next point will be 0.2 plus 0.2. That is 0.4, 0.6, 0.8, and here is your 1. Okay, so my graph I think is, okay, can I just change it first so that I can draw accurately on this? All right. Okay. So the graph will go up like that. Yeah. So upper rectangle, correct? So I draw, I use this height. So I use this height. Right? Then the second upper rectangle is this height. You see or not? So these are the rectangle. These are the upper rectangle. So when you find your AU, that means sum of the area of all upper rectangles. So the width is still 0.2. So what I can do is, I told you already, what I will do is, I will use my AL there. I put second enter. Then what I need to change is I change Y10 to Y11. Correct? I only need to change this one. So I have Y1 0.2. You write down plus Y1 0.4 plus Y1 0.6 plus Y1 0.8. Then the last one is Y11. So you get the answer. And you complete your upper rectangle. This is part A, this is part B. That's all. That is what the question means. So they just passy, they ask you to make a prediction only. So you have to, that means you have to do all to look at the pattern, then you make a prediction. So I complete this for you. So these are called the upper rectangle. So your point very important. You cannot just simply draw. Go right up and draw horizontally. So these are the upper rectangle. Okay? So the way to draw upper rectangle and lower rectangles is very simple. You determine the width, then you determine which side you must take, then draw a proper rectangle. And the rectangle must touch, one of the vertex of the rectangle must touch. Okay. Which one okay. Yeah. One of the rectangle, you must touch the graph. Understand? One of the vertex of the rectangle must touch the graph. If for lower rectangle, the lower height one touch. If for upper rectangle, the taller one touch. Can or not? You go in like that. So your rectangle cannot be out of the graph, one of the edge. Yep, must touch the graph. Okay, like this one, the lower one here touch the graph. You see or not? The edge. Maybe you want to make a point like that. So that you know which point you are supposed to take. For this one is here, 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 and here. You make a mark there. So you know which point to take. Are you okay? Okay, you have to be quick because today I want to teach 4B. Okay, can I move? Okay, so everyone go to 4B. Okay, 4B is antiderivative. So when you talk about finding the area bounded by a curve, I told you already, the area bounded by the curve of rate of change, it represents the total amount of that function. So that is the concept that you have to. And how I link it to integration, because integration also means summation. You add up all the rectangles when the number of rectangles approaches infinity. Correct? Okay, so now okay, so we are going to go to 4B. You see 4B? So what is the title of 4B? Anti-differentiation. Anti. So when you say it's anti-differentiation, that means it's a inverse of differentiation. It's the inverse of differentiation, okay? So that means the concept will be like that. If I have a function called y equal to fx, okay? When I differentiate this, I got my f prime x, correct? Hello? So therefore, if I integrate f prime x with respect to dx, I will get back my y, which is my fx. So that is the meaning of anti-differentiation. So integration means anti-differentiation, the inverse. It's exactly like in math. Math, there is a lot of operation which is inverse. Like 1 plus 2 equal to 3. So 3 minus 1 equal to 2. So these are called the inverse. plus and minus, square and square root. So all these are the inverse operation. So like for example now, okay, let's look. If I have my y equal to 3x squared, so look, so my dy dx will be equal to 6x. Am I right? So therefore, I don't have to know integration. I can say that if I integrate 6x with respect to x, I will get back my 3x squared. This is your fx. Correct? Nah? So I'm using the concept of antiderivative. So I put a plus c. Okay, can someone tell me, explain to me, why must I put a plus c? Yes. When you differentiate a constant, you get 0. So the reason why I have to plus a c is because when I have a constant, I differentiate, I get 0. So this one, I can view it as 6x plus 0. So do I change the value of 6x? No. So when you have a plus and minus for integration, you can say this is a two-part. So this is my 3x squared plus differentiate constant, you get 0. So integrate 0, you get a constant. You see or not? So that is the idea of anti-differentiation. You get me? So it's as simple as this. So don't have to think of what. So this is a very important concept here. And every time when we do integration, why we have to plus a constant, the reason is that. Because when you differentiate a constant, you get 0. So any expression, I can just add 0 to it. It doesn't change the whole thing. Am I right? So therefore, always remember. Are you okay? So now, how we are going to ask you for this kind of question in the exam to test you on this concept. Okay, so I'm going to give you a situation. I said, given fx is equal to x ln x. Okay. A, find f prime x. Then B, I will say hence find the integral of ln x dx. Okay, shall we? Okay, for this question, I will explain to you step by step. I will try to go as slow as possible. So I want you to do part A first by yourself. I want you to do part A first by yourself. You're going for your exam next Wednesday, correct? So you should know how to do part A. If you don't know how to do part A, you have to work triple hard this weekend. Okay, are you done? Okay, so I will do part A for you to see. So my fx is equal to x ln x. So this is my u, this is my v, right? So f prime x, v, usually if it involve ln, I will always bracket it up. Yeah. V, u prime is 1 plus u v prime. When you differentiate ln, you got fx put down here and f prime x put up here. Am I right? So I end up with ln x plus 1. Okay. So to do part B, listen, to do part B, we are not going to look at the problem first. Why? Because this is test you on anti-differentiation. So we are going to go back to this concept. This one. Are you okay? So I'm not going to look at the problem first because I know I can't solve the problem yet. So I'm going to use my concept of anti-differentiation. So I know that if I integrate f prime x, so I'm going to use this. If I integrate f prime x with respect to x, what will I get? What will I get? What will I get? General, what will I get? I get back my fx. So you see, this is your fx. And this is your f prime x. See or not? So what I will do is, for part B, I will write down this first straight away. My f prime x is ln x plus 1 dx. So what is the result of this integral? Okay, I will do the plus c at the end because constant, any number of constant is still a constant, okay? So we will put the constant at the end. I will not put plus c at the beginning. I will put plus c at the end. Okay, so what is the result of this integral? Can someone tell me? Okay, good. X ln x. So settle. All right? So now, I know that if I see a plus and a minus, I can break this into 2. It's not equal, so I break this into 2. Every time when you break into 2, you have to put a dx at the back. Is equal to x ln x. All right? Okay, so far so good? Okay, so now my issue is this. Okay, can you think of what is the integral of 1 dx? Okay, why they know is x? Because in their mind, maybe they got the formula, or in their mind, we have this. We know that integration is anti-differentiation, correct? If I have y equal to x, my dy dx will be equal to what? 1. So therefore, I integrate 1 dx, I will get my x. So you see, even your teacher didn't teach you integration, correct? If you know differentiation, you can get the answer. That is also one reason. Your teacher will not teach you division first before teach you multiplication. You see? So max certain things have to come in order. Yep. That's why division is harder than multiplication, because you must know multiplication first before you know division. So now I know that the result of this one I don't know the result yet, but I know the result of this, that is X. Okay, so therefore, I just operate it. X ln X minus X plus C. You bring this one over, is minus, correct? That's it. My job done. So that is how you will be tested. So whenever you do these sort of questions, I want to test your understanding of antiderivative. You get what I mean? I want to test you on antiderivative. So when you show, which step you must show? Which step show to the examiner that you understand antiderivative? The very first step. Here. So if this part is 3 marks, if you show the very first step, you get 1 mark already. The rest is modification. Are you clear? So you don't look at the problem. So for this particular question, in solving this question, correct, it is telling us that sometime in life, correct, the moment you look at your problem, correct, you'll get very upset with it. So now, don't look at your problem. Look at what you have and look at what you know. Work on it. Then at the end, your problem will be solved. Hello? So can you try this problem? 5 minutes. So now, part A. I will just dy dx is equal to v u prime plus u v prime. I purposely put a 1 here. You know what am I doing? Am I right? So this will be e to the power x plus x e to the power x. Okay. So for part B, because the question says hence, so I'm not going to look at this. No. I'm going to look at what I have in part A. Right? So I'm going to do this. If I integrate my dy dx, this is my dy dx, I will get back my y here. So every time when I do math, I always talk to myself. So now, my dy dx, there are 2 terms there. So I can separate them. I do step by step. I can separate them. See? Okay, I still didn't look at my problem. I just know that my problem got this there. Correct? So I just let it be first. I don't care about the 2 first. Okay. So now I have to ask myself, do I know what expression when I differentiate, I will get e to the power x? So I have to ask myself, okay, y equal to what? When I find my dy dx, I will get e to the power x. Through your differentiation experience, what should your y be? E to the power x. That is called experience count. Am I right? Even people don't teach you integration, experience count. Am I right? Okay. So now the result of this integral is e to the power x plus integrate x e to the power x dx is equal to x e to the power x. Right? So now the term that I'm interested is here. So if I move this term over, it will be a minus. I don't have to factorize it. Okay, good. So now only I go back to the question. I go back to the question here. So the question here, if I have a number multiplied by an expression, so I can say that this is 2 times the integral of this. Are you clear? That is the meaning of 2 times that. So now 1 time of this is equal to this. So now you tell me 2 times of this is equal to what? Is equal to 2 times of this whole thing. Am I right? And you put a plus C there. Are you okay? So that is how you work. So you see in maths, how important is it? Don't look at the problem. Look at what you know. Look at what you have and settle the problem. See or not? Step by step. So you see, if you want to score in your SAT, correct? Every lesson, there's something for you to learn. So the whole day through, you just thinking about it. When you're sitting there waiting for your friend, or you're sitting there doing that one, just look at it. Then the thing stick to your mind when come to exam, wet water. Do you know the meaning of wet water or not?